Pluto, a once proud planet of the solar system, and Neptune, its massive icy neighbor, have long been subjects of astronomical fascination. From debates about their roles in shaping the outer reaches of our cosmic neighborhood to groundbreaking studies of their unique characteristics, these celestial bodies have captured the human imagination for generations. But now, a scenario so unprecedented, so extraordinary, is unfolding. A cosmic collision between Pluto and Neptune, and it's rewriting the laws of planetary science. At first glance, the idea of Pluto colliding with Neptune seems impossible. Pluto's orbital path around the Sun is peculiar. It crosses Neptune's orbit but does so in a way that the two bodies never meet. Astronomers have marveled at this orbital resonance, a precise gravitational dance choreographed by the laws of physics. Yet, recent data from advanced observatories, including NASA's James Webb Space Telescope, has revealed a once-in-a-lifetime event, an unexpected shift in Pluto's orbit that led to its direct interaction with Neptune. How did this happen? For years, scientists have been monitoring the subtle gravitational influences of objects in the Kuiper Belt, a vast region beyond Neptune filled with icy debris and dwarf planets. A newly discovered rogue object, possibly an interstellar visitor, may have disrupted Pluto's stable orbit, setting it on a trajectory toward Neptune. This dramatic shift challenges long-standing models of planetary motion and raises profound questions about the hidden forces operating in the outer solar system. As the collision approached, the astronomical community watched in awe. State-of-the-art simulations predicted an event unlike anything seen before. Not a destructive impact, but an extraordinary cosmic merging. Pluto, with its icy surface and thin atmosphere, was set to graze Neptune's outer layers, triggering a cascade of chemical reactions and energy exchanges that would illuminate the solar system's frontier. When the event occurred, telescopes worldwide and in orbit captured the spectacle. A dazzling display of light and energy erupted as Neptune's atmosphere absorbed Pluto's material. High-speed cameras documented enormous plumes of methane, nitrogen, and other elements shooting into space, creating a vivid auroral glow around Neptune's poles. But the collision wasn't merely a visual phenomenon, it also had profound scientific implications. Early observations indicate that the interaction has fundamentally altered both celestial bodies. Pluto's icy crust has been partially stripped away, exposing its mysterious core, a feature scientists have long theorized but never observed. Neptune, meanwhile, is undergoing unprecedented atmospheric changes. Enhanced activity in its cloud bands and a rapid intensification of its storms suggest that Pluto's collision has injected enormous amounts of energy into the planet's systems. These transformations could redefine our understanding of the outer planets. For decades, Neptune has been considered a relatively quiet giant, its deep blue hues masking turbulent but stable weather patterns. The collision has shattered this perception, revealing dynamic processes that could reshape Neptune's atmosphere for centuries to come. Meanwhile, the event has sparked new questions about Pluto's role in the solar system. Once demoted to a dwarf planet, Pluto's dramatic interaction with Neptune has reignited debates about its classification. Could this cosmic collision elevate Pluto's status, proving it to be a significant planetary player capable of influencing its larger neighbors? Scientists are also considering the broader implications for planetary systems beyond our own. If such interactions can occur in the solar system, what might they reveal about exoplanetary systems? Could similar collisions in distant star systems spark the formation of new worlds or trigger the conditions necessary for life? Moreover, the collision has opened a new chapter in the study of planetary evolution. By analyzing the material exchange between Neptune and Pluto, researchers hope to uncover clues about the early solar system's formation. The outer planets are thought to hold some of the oldest and most pristine materials in the solar system, and this event provides a unique opportunity to study them up close. But the most astonishing discovery came from the data collected by the James Webb Space Telescope and other advanced observatories. Among the ejected material, scientists detected unexpected chemical signatures, compounds that suggest the presence of organic molecules. This finding has sparked intense speculation about the possibility that Pluto, despite its icy and inhospitable environment, may harbor or once harbored, the building blocks of life. Astronomers and planetary scientists are now racing to deploy additional probes and telescopes to study the aftermath of the collision. Missions originally designed to explore the Kuiper Belt are being redirected toward Neptune to capture detailed images and measurements of the transformed planet. At the same time, robotic explorers are being proposed to investigate the remnants of Pluto and its interaction zone. While the collision marks the end of Pluto's independent journey through the solar system, it also signals the beginning of an era of profound discovery. The event has captivated not only the scientific community but also the public imagination, sparking renewed interest in space exploration and the mysteries of the cosmos. The collision of Pluto and Neptune has also sparked significant developments in our technological and observational capabilities. Scientists are now leveraging this monumental event to refine our space monitoring tools and computational models. By observing the aftermath in real time, we're gaining invaluable data on how planetary atmospheres respond to massive energy exchanges. This, in turn, allows us to simulate similar phenomena with greater precision, paving the way for future breakthroughs in astrophysics. One of the most exciting aspects of this cosmic event is its potential to unlock secrets about the solar system's frozen frontier. Pluto and Neptune are key players in this region, representing the transition between the classical planets and the icy debris of the Kuiper Belt. As their materials intermingle, scientists are analyzing the ejected plumes for insights into their chemical composition. Early findings suggest the presence of exotic ices, such as hydrogen sulfide and carbon monoxide, which may shed light on the conditions that prevailed during the solar system's formation. The collision has also brought attention to an intriguing question: what does this mean for the stability of the outer solar system? While Neptune and Pluto's orbits were long considered secure, this event demonstrates that even minor perturbations can have dramatic consequences. Could other Kuiper Belt objects or dwarf planets face similar fates? Might gravitational interactions with Neptune or other planets eventually alter their orbits as well? Some researchers believe this event could serve as a precursor to future disruptions in the Kuiper Belt. The gravitational interplay between Neptune and these distant objects might lead to new collisions, ejections, or even the creation of temporary moons. Such events could provide further opportunities to study planetary dynamics, but they also underscore the need for vigilant monitoring of our cosmic neighborhood. Public fascination with this event has reached unprecedented levels, with millions around the globe tuning in to watch live streams of the collision and its aftermath. The dazzling visuals, ranging from Neptune's glowing auroras to the shimmering trails of debris, have captivated audiences, while the scientific implications have sparked widespread curiosity. Social media is abuzz with questions about what this event reveals about our place in the universe and what it might mean for humanity's future in space exploration. In response to this heightened interest, space agencies worldwide are accelerating their plans for new exploratory missions. NASA and ESA have announced joint proposals to send a state-of-the-art spacecraft to Neptune, equipped with advanced spectrometers, high-resolution cameras, and atmospheric probes. This mission, tentatively named Poseidon Explorer, aims to study the transformed Neptune in unprecedented detail, while also capturing any remnants of Pluto still lingering in the vicinity. Meanwhile, private space companies are getting involved as well. Visionaries like Elon Musk and other industry leaders see this as an opportunity to demonstrate the capabilities of their cutting-edge technologies. Discussions are already underway about launching rapid response missions to capture unique data before the collision's aftereffects dissipate. On a broader scale, the Pluto-Neptune collision has reinvigorated debates about humanity's role in the cosmos. The dramatic nature of the event serves as a powerful reminder of the dynamic and unpredictable nature of our universe. For many, it underscores the importance of expanding our presence in space, not only to explore but also to protect our planet from potential cosmic threats. Theories about the origins of life are also being revisited in light of the organic molecules detected in the debris. If Pluto, a frozen dwarf planet far from the Sun, contains the precursors to life, what does this imply about other icy worlds in our solar system and beyond? Could moons like Europa, Enceladus, or Titan harbor similar organic compounds, potentially fostering microbial ecosystems beneath their icy shells? Some scientists are even speculating that the collision could have implications for panspermia, the theory that life can be transferred between celestial bodies. If organic material from Pluto is ejected into space, it could potentially travel vast distances, perhaps even seeding life on other worlds. While this idea remains speculative, the discovery of organic molecules in the collision's aftermath lends it newfound credibility. As humanity grapples with these profound questions, one thing is certain: the Pluto-Neptune collision marks a watershed moment in our understanding of the universe. It's a stark reminder of the dynamic forces shaping our solar system and a testament to the power of science and technology to unravel its mysteries. In the coming months and years, as more data is collected and analyzed, we'll undoubtedly learn even more about this extraordinary event. Each new discovery will add to our growing understanding of the cosmos and inspire future generations of scientists, engineers, and explorers to reach for the stars. For now, we stand on the precipice of an exciting new era in planetary science. The collision of Pluto and Neptune is more than just a spectacular event. It's a window into the past, a laboratory for the present, and a beacon for the future.